trying to think, okay, is there anything I remember? And the only thing I could remember is that there was this keyword, dark, probably in the title. So the first thing that I did, I opened Spotify and I searched dark. And it turns out that that was not very helpful because the search in Spotify, let's say, is not great. You get up to 1,000 items and then that stops. So that didn't really help me much. And then I remember that I've been using this website for a long time. I don't know if you know it because it's not very mainstream. It's called Last.fm. And what Last.fm does has like plugins for the different media players, including Spotify. And it creates like a little database of all the songs that you have been listening to every time, basically, in your history. And it's kind of a little social media application where you can basically connect with people that have similar musical taste. You can discover new groups. So I've been using this for a while. And you can see here that I have been there since 2007. And I have scrobbles, which is the way, the word that Last.fm defines songs recorded in your profile. I have more than 250,000 in there. So from 2007, all these songs recorded, I think the song that I'm looking for must be in this data set there. So as a developer, what do? The first thing that I do is like, oh, is there an API for this? Let's check it out. And it turns out that there is an API. It's actually a very old API. You can tell by the XML there that, yeah. Thankfully, they also support a JSON mode if you enable it. So we are going to be able to do JSON and not having to deal with XML. So I was trying to look in this API, what kind of method can we use to get the list, the full history of all my songs, so I can start to use that data and search for this particular keyword, dark. And I found this API and seems like the right one we want to use. So I tried, okay, let's just get an API key and let's try this API and see what happens. And basically it was giving me back records. I don't know if you can see it because it's very small, but the way the API looks like is like, yeah, there is pages, and for every page you have tracks, so it seems like it's working. But because we want to do some custom logic, let's rewrite all of that in JavaScript, so we're going to be able to do the same things in JavaScript and more. So basically what I did, I created a little script using this web client called Undici, which is actually very cool. If you haven't used it yet, I recommend it. And then basically I created a query object. With that query object, I have all the parameters that are needed to call the API. I use it to build a URL. I do a request, and then basically await that request, get the response as a JSON, and log that data. So this is almost the same code that we were doing before with curl, but now we have JavaScript, so we can keep building on top of this code. And the result is pretty much the same, except that, of course, we can see the response a little bit better. There is like a metadata section where we get the number of pages, how many elements in total, how many elements per page. And then we have another section with all the records for the current page. Now there is a little caveat here. It's saying that there are 50 records per page, but there are actually 51, which is weird. Let's ignore this for a second. We'll come back to it. So the next question is, okay, we are fetching the data in the first page. How do we go to the next one? And I realized that there is another query string parameter that we can use called page that we can keep increasing and traverse page 1, page 2, page 3, and so on. So let's update the code. What can we do? We can create a variable, page equal 1. Then we do a while loop. Everything else is pretty much the same, except we need to pass now the current page in the query string. And then we need to have a condition to actually break this loop when we are at the last page. Of course, we don't need to forget that at every iteration, we need to increase the counter of the page. So if we run this code, you can probably see, maybe, that there is a page counter that is increasing, and we get more and more data. So this kind of seemed to work. Now let's look at the actual data to see if the data makes sense. And an easy way that we can do that, again, we can simply just iterate over all the tracks for every page and just print the name of the artist and the name of the song. And also we added a little end page there just to make sure that we can visualize all the data and understand how the pagination works. And that was convenient because we immediately realized that there are a few problems. The first one is that there is always a first song that has an undefined timestamp. And then it turns out that this is the problem why we have 51 songs, because basically that song shows up only if I'm listening to something while I'm going through the data. So for every page, if I'm listening to something right now, that song will be the first one in every page, which may be annoying, but we should be able to filter that out very easily. Then the next problem is that there are duplicated songs between pages. And it's not like this is like the same song I was listening to it twice, because if you look at the timestamp, it's literally the same timestamp. So there is duplicated record here between the pages. So this is actually a very common problem with paginated APIs. It's called the sliding windows problem, or at least that's what I like to call it. So let's explore it a little bit more, and let's try to understand what's going on here. So keep in mind we are visiting records, and we are visiting records in pages. So here, for instance, we have 5 records per page. We have page 1 and page 2. And this is a very dynamic collection. So while I'm going through this data, probably I'm listening to some music. So this data is changing all the time. And if there is a new record, that record will go in front. So what happens if you look at the pages now is that basically everything is shifted a little bit. And what was the last record of the first page now became the first record of the second page. So basically where we were seeing duplication of data is because a new record just came in, and then all the pagination shifted a little bit, so we were seeing that record twice. And of course, we are developers. It's not really a big deal, but we want to fix that bug and make it right. So how do we do that? So let's look at the documentation again, and we realize that there is another parameter called to, and maybe we can use this parameter instead of the pagination with the counter 1, 2, 3, and 4. And what to does is basically allows us to give us a timestamp and say, take all the data from this point in time and move on that way. And this is basically time-based windowing across the data. So if we try to visualize what happens, is basically we have tracks from the newest to the oldest. We divide things by page, but this time we only care about fetching the first page. Once we do that, how do we fetch the next page? We look at the last record, we take the timestamp, and then we use that timestamp as a reference to say, next page starts from this timestamp. And we do that with the parameter to. It's a little bit confusing because we are using to and not from, but keep in mind that the data is in reverse order. We have the newest data first and the oldest last. So that's why from and to might be a little bit confusing. So we can keep doing this and basically visit every page until we get to the point where there is no next page. If you go to the next page, the remaining number of pages is 0. So let's update the code to do that. Now we have a new parameter called to. We pass this parameter. At the beginning is empty because when it's undefined, lastFM is just going to give you the most recent data. And then we need to change the stop condition because now we just check what is the total number of remaining pages. If that's 1 or less than 1, it means that either we are in the last page now or we just skipped past the last page. So at that point, we can just break. And of course, we need to update this counter to by looking at the last record of this page and taking the timestamp. Okay, so if we look at the data now, it kind of makes sense. We can see that there are no more duplicates. So, and the boundaries make sense here in this visualization. So we are really happy with this solution. And this is the point where I stopped because I said, okay, I'm trying to scratch my own itch because I want to solve a problem for myself, but I already did a lot of work. So maybe here there is an opportunity to build a library for other people that have the same problem, and maybe they want to use this data to do something useful with it. So I kind of stopped at this point and I started to think, how do I build a library out of this? And how can we make it useful and user-friendly for people to use? So I started to think about, okay, what kind of interface are we going to give to people for this data that comes in asynchronously over time, and you have chunks of data step by step. And I thought, okay, maybe I can build an abstraction, something we can call a reader that you configure with all the parameters, like your username and the API key, and then you can use this object to get the data and process the data as it arrives. But how can we build this reader? What kind of techniques do we know in JavaScript and Node.js? And the first thing that came to my mind is, okay, we could use callbacks. We could create a method in this object called readPages, and we can pass callbacks to this method to say, every time there is a new page, run this callback and do something with it, or if there is an error, run this callback, and deal with the error. That's one way, but it seems that the world is moving away from callbacks, so maybe let's see if there is an alternative. And the other alternative that came to my mind is event emitters, which is very common in Node.js. So the idea is that we can have a method called read. When we call that method, it starts fetching the data, and then we can attach event listeners to this object to say, for instance, every time there is an event called page, do something. Every time there is an event called completed, do something. We could have an event called on error, for instance, or we can handle errors in the completed one as well. So that could be another option, but again, it feels very callback oriented because with event emitters, you are still passing a callback function. So again, let's think more and let's see if there is another solution. And I love streams. I'm not going to spoil it too much because we have an entire talk by Eric later on about streams. So if you want to know more about stream, make sure to follow. But just to give you a taste, streams are actually another way to solve this problem of asynchronous data coming in. They are event emitters, so we can use pretty much the same interface as before. But you can also use the pipeline function, which allows you to compose fetching the data with your own business logic to process the data as it comes in. And streams are pretty cool, but I was thinking, okay, I'm almost tempted to use streams, but can we do better? Can we do something more innovative and easy to use for people? And then I realized, it would be very nice if you can just do a for-await loop on this data and just process it as if it was synchronous data coming in. And how do we do that? Well, it turns out that if we define our object as an async iterator, then we'll be able to actually run this code and say, for await every single page of the reader object, and then inside this loop, we can handle the data for every single page. And this is amazing because it looks very synchronous. We don't have to think about, what's going to happen first, this event or that other event. What do I do if there is an error? Is something happening in between? This looks very synchronous, easy to read from top to bottom. And the best part is that you can even deal with errors, because if you put a try-catch, that try-catch will catch both synchronous and asynchronous error, and you will have a unique catch block to deal with errors. So I really want to build it this way. How do we do it? Let's figure it out. And in order to figure it out, we have to go a little bit back and discuss all the iteration protocols in JavaScript. And of course, they apply also to Node.js. But before we do that, let's clarify two concepts that I found personally confusing, and I see people using them interchangeably, even though they have very specific definition and very specific protocol, so we need to be able to distinguish them. And the first one is iterator. And you can imagine an iterator as an arrow. It doesn't really know anything about the data structure itself. It just knows that you can move it to the next element. And then it knows when it reached the end of the items. So the idea of an iterator is literally like a cursor that you have, and you can just move it to the next position. Instead, the idea of an iterable is a little bit more generic, because the idea of a collection that can be either all in memory or can be like a collection that gets generated as you go. And you can get an iterator from that collection if you want to go through all the data in order. So iterable, imagine a collection. Iterator, imagine an arrow that points in one element of that collection, and you can use it to move around. So the first protocol is the iterator protocol. And the iterator protocol says that an object in JavaScript, to be considered an iterator, needs to have a method called next. And every time you call this method, it needs to return a specific object that needs to have two keys. One Boolean key called done, which indicates that is this the last element or not, and then a specific value that is the value we are getting from the current iteration. So where the arrow is actually pointing at right now. One example that we can build just to practice and see really how to implement this protocol is imagine a countdown. So we start from a number, let's say 3, and every time we iterate, we want to get 3, 2, 1, 0, and then we stop. So how do we make, this is like a factory function, and we want this factory function to return an object that is an iterator. So how do we say that this is an iterator? It needs to implement the protocol, so the object needs to have a method called next, and this method can return either done true or done with false and a specific value. So this is how we implement a countdown, which is an iterator. And how do we use it? We create the countdown object, and then we can keep call next, 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 next. And every time we get value 3, value 2, value 1, value 0, and then done true. Now, an interesting thing, if you know generators in JavaScript, they automatically produce iterator objects. So we could rewrite the same thing in a much nicer way by just using this syntax. So a generator is basically a function with just an asterisk before the function name. And that asterisk gives you a superpower. And the superpower is that you can use the yield keyword. And what yield does is basically it's going to be able to suspend the execution of that function. It's going to remember exactly all the state of the variables up to the last call. And then the next time you call again an iteration, it's going to resume the iteration exactly from that point. And when we reach the end of the execution, it's like the iterator has completed. So we don't need to think about, okay, when do I return done true? When do I return something else? I just basically yield data until there is no more data to yield. So if we write that code, it works exactly the same way. We just create the countdown, and we just keep calling next. Now let's think about the iterable protocol. The iterable protocol basically says that an object is considered an iterable if it has a very special method called symbol.iterator, and this method doesn't receive any argument and returns an iterator. So it's basically saying, I am a collection, I can give you an iterator, just call this function and I'm going to give you an iterator. And that's what makes an object iterable. So if we want to apply this idea to our countdown, so we want to make a countdown iterable, the only difference is that basically we have here this symbol.iterator, and it returns the same object that we were returning before. So the code inside this function is exactly the same as before. So it's like we are adding an additional level of abstraction saying, if you need an iterator, I can create one for you and you can use it. And the interesting thing is that we can also use generator, because we saw that generators allows us to produce an iterator object, and the code is simplified a lot. But the interesting thing is that when an object is an iterable, then we can use this syntax for off, which is much nicer because we don't have to check, is it done, call next otherwise, is it done, call next otherwise, and then manage the loop ourselves. And we also need to say, okay, give me the value with dot value, dot value, dot value. With for off, you just run a for loop and you get the value straight away, and the loop is going to stop when done is true. So far you might have noticed that all this stuff is synchronous. What if I want to do the things that we are trying to do, call APIs or other operations that are asynchronous? We cannot use these protocols because they don't seem to support anything asynchronous like callbacks or promises or stuff like that. So what do we do? Well, it turns out that there are equivalent versions of these protocols, but async. So there is an async iterator and an async iterable. So let's see what is the difference between the two counterparts. For iterators, it's basically an object always has a next method, but this time it returns a promise, and that promise needs to resolve to a done and value type of object. So it's literally the same thing. The only difference is that this time we are returning a promise, and that promise encapsulates all the asynchronous operation that eventually returns the data in the same shape as the synchronous version. And we can update our example. This time we really want to wait 1 second before the next number in the countdown. So what we can do is we want to return a promise, so we can just make the next function async. Then we await a certain amount of seconds, like 1 second, for example. And then we return our value either done true or done false with next value. And this is going to work because the promise is going to resolve when we hit the return statement, and it's going to resolve to an object that has the shape that we expect. How do you use it? Exactly like before, except that now, because we receive promises, before calling next again, we need to await for that promise to be completed. So it's like every step there is a wait time, so you need to wait, and then you can do the next step again. And if you run this code, you can see that every item comes up with a little bit of delay. And basically, this is because we are waiting for 1 second between one item and the next. Now, of course, this is a silly example, but imagine that you are calling the last.fm API to get the next page for every iteration. And one interesting thing is that, again, you can use generators, and this time you end up with a function that is both async and a generator, so they are called async generators. And you have the two superpowers. You have both the async and the asterisk, so you can use both await and yield inside the function body. So this is just a nice trick if you want to simplify writing async iterators. So there is also the async iterable, and guess what is almost the same. You need to have a special method called symbol.async iterator that returns an async iterator. So that should be fairly easy at this point. And here we can also update our example to use this symbol.async iterator, and that returns an iterator. Now, hot tip, if you use generators, actually the object that you get is not just an iterator, but it's also an iterable. So we can basically rewrite all our code with just this one function. And this is going to be both an iterator and an iterable, which means that we can just do a for await and get all the value from the iterator. So if we run this code, we can see that we get 3, 2, 1, and 0. And it's nice because the code is very readable. We don't have to think when do we stop the iteration. It's like a regular for loop, but it's going to handle all the asynchronicity for you. It's going to decide when to go to the next step, only when that promise is resolved. But you don't have to do any of that stuff. It's just going to do it for you. Perfect. So we are almost at the end. And let's update now our code. Now that we understand how to make something an async iterable, let's do it. And what do we need to do? Basically, because we know that we can just use async generators, we basically turn our function into an async generator. That means that inside this function, we can use both await and yield. When do we yield? Every time that there is a page, we yield that value, which is basically the way that we are giving a user of this library control over the data. So the user will just be able to say for await, and for every loop, they basically get the data that is yielded at this point. And this will keep going in a loop until we reach the very last page. So now at this point, we can actually do what we wanted to do, which is give me an object, and I just want to do a for await on that object. And I know that for every iteration of the loop, I'm just going to get a part of my music history, and I can use that to start to search over the data. So if we run this code, which is very small, maybe now it's a little bit more readable, you can see that basically it produces a lot of data, and we are basically printing page by page. So now the last thing that is left to do is solve again our own problem. So let's become again the users of our library that we just created, and let's try to implement this particular search. We want to search for the keyword dark in the title. So it's very simple. What we need to do is for await, and then in every page, we know that we have a list of records. So for every track in that page, just print that track if the title includes the keyword dark. And basically, I wrote the script and I ran it. And after, I think, something like 30 minutes, I arrived at some point where I started to see this particular track. And I remember from the title that this was the song that I was looking for. And it was from 9 years ago. Don't ask me what was going on with my brain, because suddenly a random song from 9 years before just popped up. But I finally could listen to it, so I was really happy. Okay, I'm going to leave you with one last resource. I created a small workshop that you can do online. It's totally open source, so you just pull the repository and there are explanations and exercises and examples. If you want to learn more about all the iteration protocols, about generators, async generators, so check it out. If you find it interesting, let me know. If you find issues, it's open source, so you can also contribute to it. And I hope that this was interesting and that now you also feel like you learned something new and you can use these new tools next time you have a similar use case. Thank you very much, everyone.